your company really needs to be aware of what the arc flash standard is and what the arc flash hazard awareness is. So the arc flash standard falls under what's called NFPA 70E, or the arc flash, the NFPA, National Fire Protection Association. It's a consensus standard. And the arc flash standard has been around for a long time, but surprisingly, a lot of companies aren't aware of the requirements, or if they are aware of it, haven't implemented the necessary tools and put the necessary resources into protecting employees. And hopefully after today's presentation, you'll have a very good understanding of what the requirements are. Again, this is going to be an introduction to the standard, why it's important to train your employees and equip your employees to protect against an arc flash, and as the moderator indicated, at the end, if there are any questions, if there are any comments, if there are any case scenarios, I welcome those and we'll go through those. So, what is an arc flash hazard? Well, starts out a dangerous condition associated with the release of energy caused by an electric arc. And arc flash incidents are really horrific things. They happen so suddenly and so severely, and time permitting, I would pull up a video on showing you different arc flash scenarios occurring. But these things happen in milliseconds, and you have such extreme forces coming at you. It's the equivalent of a bomb going off in a lot of ways. And when we get to the arc flash PPE requirements, personal protective equipment requirements, as we get up into what's called the higher kilocalorie range, or the calometers, or the calories per centimeter squared, the energy potential release, the personal protective equipment is very similar in a lot of ways to what a bomb disposal technician wears. So it's important to make sure that you implement arc flash at your facility and do an arc flash hazard analysis. And arc flash hazard analysis are an in-depth study investigating a worker's potential exposure to arc flash energy, conducted for the purpose of injury prevention and determination of safe work practices and appropriate levels of personal protective equipment. It's a methodical, detailed, step-by-step analysis done by an electrical engineer or somebody that has that equivalent background, looking at each piece of equipment, evaluating each piece of equipment in your plant for the potential for an arc flash, and making sure it's safe and meeting the NFPA, National Fire Protection Association, and NEC, National Electric Code guidelines. So why is arc flash important? Well, unfortunately, according to the National Fire Protection Association, there's an average of 4,000 non-disabling and 3,600 disabling electrical contact injuries annually in the United States. That's a lot of injuries, and a lot of these are burns and severe burns. I don't know if any of you have ever been to a burn center. I have dealt with severe burns. I've dealt with the fatality involving burns before, and burns are some of the worst injuries, in my opinion, a person can have, especially second and third degree burns that cover extensive portions of the body, which you get with arc flash events, because the body cannot heal itself. Without getting too much into it, in order to heal from a second or third degree burn, again, depending on the extent, synthetic skin has to be used. You basically have an open wound where the burn is. Debridement has to occur every day or every other day, scraping away of the dead skin. Cadaver skin is used to cover. It is very common for burns of that magnitude to have infections set in, and extremely, extremely painful. Burn centers are, the treatment somebody that is burned gets at a burn center is outstanding. I don't mean to knock it in any way, shape, or form, but are one of the most, in my opinion, saddest and depressing areas to be in, because it takes so long for a worker or an employee to recover from a burn like that. And that's what is the most common injury with an arc flash. And 1 person is electrocuted in the workplace every day. So pretty sobering statistics. According to the National Fire Protection Association, electrocutions were the 4th leading cause of traumatic occupational fatalities. And we talked, just a few minutes ago about burn centers. Well, over 2,000 workers are sent to burn centers each year with electrical burns. And again, burns being some of the most catastrophic injuries somebody can get, and painful, and just, if they recover, their lives and their families' lives and their coworkers' lives are forever changed. Why is arc flash important? Well, arc plasma temperatures, when the arc flash or arc blast occur, can reach temperatures that are 35,000 degrees. Let me repeat that, 35,000 degrees. I've done this training, this awareness training, a number of times now, and that is still hard for me to wrap my brain around, that how hot that is. That is literally almost 4 times hotter than the sun's surface. Any material known to man or woman vaporizes at that temperature. And 80% of all electric injuries are burns from electric arc flash and ignition of employees' clothing. So you have the arc flash event, the explosion. We'll talk about some of the hazards associated with the arc flash. But again, very common if somebody doesn't have the right arc flash personal protective equipment on, their clothing will catch on fire. If they have synthetic clothes underneath, even if it's a arc flash rated suit, any synthetic material, that can literally melt to the skin. And I apologize, I don't mean to get too graphic, but with summer around the corner, may not feel like it in some areas of the country, but does here in Mississippi, where I'm based. People are firing up the grills, or will be. They're cleaning grills using, that scraping tool. And if you've operated a grill, I'm talking about, to really clean that. That scraping tool, or that wire brush, now it's different, but it's the same type of instrument that is used to scrape that synthetic material that is melted to the skin, or somebody has a watch that gets melted, embedded in the skin. They have to use that to scrape that off. So, again, just picture that. And that's why we're doing what we're doing with this arc flash standard. 80% of all electrical injuries are burns, again, from employees' clothing igniting or synthetic material being underneath. Okay, this pictographic, courtesy of the National Fire Protection Association, does a very good job of highlighting the hazards. And I encourage you to, after this presentation, and again, due to time constraints, I'm not able to do it, but just Google on YouTube arc flash events, and you will see how suddenly this and severely this occurs. This happens in milliseconds. I've done training, and I've had, believe it or not, some electricians argue with me saying, well, I've been doing this for 25, 30 years. This would never happen to me. Well, that's that complacency factor kicking in. And you don't have to actively do something for an arc flash event to occur. You can just be walking by a piece of equipment and an arc occurs, and without even touching the equipment, one of these can occur. The other thing is, I've had some electricians argue with me, well, if I see it, I can jump out of the way. And that's just physically impossible. By the time this happens, again, it's very similar to a bomb going off in a lot of ways, with the intensity, with the severity, and how quickly. This happens in milliseconds, thousandths of a second. Your brain, even if you were looking and seeing it occur, by the time this occurs, it's over before your brain can really process it. Because again, it happens in thousandths of a second. So when an arc flash occurs or an arc blast occurs, you have temperatures that reach 35,000 degrees. Again, vaporizes any material known to man or woman. You've got molten metal coming out at you. You've got pressure waves coming out at you. Sound waves. It's very common in these type, obviously burns are the most catastrophic event, but people have blown eardrums because of the severity of the shock waves and the sound waves. Pardon me, you get shrapnel coming at you. Hot, rapid air expansion, very intense light in copper vapor. Solid to vapor expands by 67,000 times. So can you imagine breathing that copper vapor in, and it expands by 67,000 times in your lungs? What damage that does to your lungs and your circulatory system and your respiratory system. So all of these things are happening at once. That's why we need to protect ourselves. So, again, to summarize, you've got thermal hazards, pressure hazards, auditory hazards, projectiles, and inhalation hazards all coming at you or your employees at once. And it is physically impossible to jump out of the way. All right, NFPA 70E articles. So Article 110 covers general requirements for electrically safe work practices. So there are training requirements, and this training, by the way, is just an awareness level training. It's training you and hopefully your employees or your team, management team, leadership team, maintenance team, whatever, about what the standard is. Electrical safety program and use of equipment. NFPA 70E articles. Articles 120 talks about requirements for establishing safe work conditions. Obviously, this falls under electrically safe work practices. So OSHA requires to have a lockout tagout program, or lock tag try as it's now often called, or tryout. The try being the verification of energy isolation before a piece of equipment is worked on. So before any piece of equipment is worked on, ideally, if at all possible, it should be de-energized. All energy sources isolated. In this case, we're talking about electric, but excuse me, that can include pneumatic, hydraulic, kinetic energy, stored energy, etc., before work commences. Now, if something has to be worked on while it's live, ideally, again, you want everything at a zero energy state, being locked out, tag out. But if somebody has to troubleshoot, or the example I give, this is kind of an extreme example, but it makes the case. If you've got somebody in a hospital and they're on life support equipment, obviously, and there's some kind of fault or trouble with it, somebody's not going to be able to de-energize that, right, for obvious reasons. They're going to have to work on it live. Well, there's very specific requirements under NFPA 70E. Article 130 talks about working on or near live parts. It's designed to prevent electrocution and arc flash protection. So arc flash falls under electrical safety hazards. So you get personnel involved, you've got electric shock, you have the arc flash and the arc blast. And those terms are used interchangeably. The arc flash is the initial event. The arc blast is the explosion, if you will, or that shrapnel that flies out, the high thermal temperatures, etc. And falls. Oftentimes, a lot of people don't think about falls occurring. But again, because of the intensity and how quickly this occurs, if you've got somebody working, let's say, in a ladder or on a mezzanine or in some kind of JLG or scissors lift or something like that, the blast can literally knock them back and create a fall hazard or, sad enough, a fatality. Now, the main thing we're concerned about with arc flash protection is people. But arc flashes and arc blasts can cause significant property damage. It can create fires. It can create equipment damage. I've seen whole plants taken down, or portions of a plant taken down for an extended period of time. That's a lot of lost downtime. That's a lot. And in addition to lost downtime, having your plant down creates in and of itself pressure to get the plant back up and running, right? So that creates upset conditions that, maintenance workers, electricians, engineers, et cetera, are working, under a lot of pressure to get things up and running, and that in and itself can create opportunities for accidents to occur. So why is arc flash important? Well, according to the NFPA, a shock requires exposure to a difference of potential. The National Electric Code, or NEC, reduces this risk under normal conditions, but NFPA 70E reduces this risk under abnormal conditions, which an arc flash or an arc blast can occur or will occur. Some frequent causes of arc flash incidents, and this is by no means an all-inclusive list, but covers some of the highlights. Extended maintenance cycles, so putting off preventive maintenance when it should be done. Pardon me while I get a drink. Not maintaining equipment properly. Extreme environments. And again, if you've been following the news, I'm based in Jackson, Mississippi. We had that record flooding here that's now finally starting to tail off. But that's an example of an extreme environment where half of downtown Jackson was underwater for an extended period of time. Again, here in Mississippi, it's not uncommon in the summer for it to get 90, 100 degrees with very high humidity. Certainly I'm from Michigan originally, so in the northern climates where you get snow and ice, all those things factor in, okay? Improper PPE requirements, not having the right PPE, missing or ineffective hazard labeling. We'll talk about hazard labeling here in a few slides. Unsafe work practices, not following the NFPA 70E guidelines, not having the right PPE on, etc. And complacency. If there was one word I could eliminate from the English vocabulary in safety, it'd be complacency, that feeling that it will never happen to me. I've done it 20, 25 years. I know what I'm doing. And it just takes that split second, somebody to be sidetracked. It may be something job-related. It may be something personal. Somebody might be going through a rough time in their personal life or a combination thereof to create an arc flash event. Okay, and usually I'll use this as a discussion point, and because, again, of time limitations, but when you do this training, ask, I would recommend, has anybody ever been shocked before? And of course, most likely the answer is yes. I know I have. Hopefully it hasn't been severe. But a shock is received when current passes through the body. The severity of the shock is going to depend on the path of the current through the body, the amount of current flowing through the body, and the length of time the body is in the circuit. Now, one misconception that I hope after this presentation will help mitigate is, our misunderstanding is, low voltage does not mean no hazards. Now, the lower the voltage, the less opportunity an arc flash occurs, but low voltage can still cause catastrophic events. So currents less than 50 milliamps or milliamperes, and that's not a lot of power, can cause ventricular fibrillation. That's that rapid, ineffective heartbeat. If you've been trained in first aid, CPR, and AED use, AED being an automatic external defibrillator, an AED is used for this particular event, that ventricular fibrillation. So somebody's having a heart attack and their heart goes into an abnormal rhythm and it's beating rapidly or more rapidly than it should, that AED will shock it back into, or try to help shock it back into rhythm. That's what it's talking about. And, if an AED isn't used or defibrillator, death can occur within a few minutes. And 50 milliamps is not a lot of current. A small electrical power tool, which we've all used, I'm sure, uses 30 times as much power. Okay, effects of current, again, just training awareness. More than 3 milliamps, we get that painful shock. I think most or not all of us has probably experienced that at one point in time. I know I have. More than 10 milliamps, again, very, very low power, but it's that muscle contraction. You cannot let go. The muscles literally contract, and that's why, when you do your training for electrically safe work practices, if somebody's being shocked, you train them, you use non-conductive material to pull them away, like a board or a fiberglass tool, something like that. By the way, a ground fault circuit interrupter, GFCI, trips at about 5 milliamps, just to kind of put it in perspective. More than 30 milliamps, lung paralysis, usually temporary, but I don't know about you, but I don't want my lungs shutting down, even for a temporary. I don't think anybody would. More than 50 milliamps. Okay, possible ventricular fibrillation. We talked about that. Heart dysfunction, usually fatal. 100 milliamps to 4 amps, certain to cause ventricular fibrillation. Again, rapid ineffective heartbeat is going to be fatal. Over 4 amps, again, that's not a lot of power. Heart paralysis, severe burns, usually caused by working under 600 volts, which a lot of companies have. So, again, even a small amount of current can be very, very detrimental and potentially can be fatal. Okay, the first rule that you should have in your company is only trained and authorized personnel that are fully trained should work around potential electric arc flash hazards. That's the bottom line. Unless you are certified, your training, you've got your program in place, ideally you should have done, or hopefully after this training you will have an arc flash hazard analysis or hazard evaluation done to identify. You don't want your workers exposed to that. And you certainly don't want unauthorized personnel in the area. And that gets into restricted, limited, and different approach boundaries. And we'll be talking about that in a little bit. But the idea being that anyone that isn't trained and authorized and that's not equipped with the arc flash PPE should not be around that area. All right, arc flash safety requirements. Effective arc flash safety requirements protect authorized and trained personnel while working on or servicing equipment that can potentially cause electrical shock hazards. An arc flash hazard exists if an authorized employee might be exposed to a significant thermal hazard as a direct result of an arc flash event. So, again, I think I've covered pretty well what the arc flash hazards are, but those videos can be very effective in really driving the point home. So I encourage you to, as I said before, just do a simple YouTube search or Google search on arc flash events. Now, they can be pretty graphic, but, the simulated ones aren't graphic, but they can show how quickly and how suddenly these occur. And they're very much attention grabbers in reinforcing these key points. Okay, so we talked about in arc flash what the hazards are. Let's talk about managing arc flash. So arc flash hazards depend on the energy available, the distance from the arc flash, and the duration of the arc flash. So the more distance you can put between an employee that's authorized and the piece of equipment, the better. And some equipment, if it's, and we'll get into this when we get into the arc flash hazard ratings, but if it's above 40 kilocalories or more, work is really or should be prohibited from occurring, because as good as arc flash personal protective equipment is, and the technology has evolved and continues to evolve and can be very effective in preventing or helping to reduce the severity of an arc flash event and preventing burns, or mitigating burns, the human body can only absorb so much energy. That's why anything 40 kilocalories and above, or calories per centimeter squared, the energy potential release from the arc flash, the body just can't take it, even with the arc flash PPE. So things like robotics, working from a distance, working remotely, those kind of protections are really good and very effective in protecting both employees and personnel. So I touched on this, but let's get into distance boundaries because this is an important part of the process. So there's two types. You have approach boundaries are used to reduce shock hazard, and a flash protection boundary is used to reduce arc flash hazards and may reduce arc blast hazards. Now keep in mind, the arc flash is the initial event and the blast is the explosion that comes out. You'll hear those terms interchangeably. They are two different things, but they certainly tie together because one happens right after the other and almost simultaneously. So the limited approach boundary is the closest distance and unqualified, and that's in quotes for a reason. We'll get to that here shortly. Person can approach the area where the electric work is being performed. And the limited approach boundary for voltages below 600 volts is 4 feet per NFPA 70E arc flash guidelines. Now let's talk about an unqualified person. I am not a qualified electrician. Be the first to admit that. I can train on the standard, I can do audits to the standard, but I don't have the requisite skill set to be working on like an MCC bucket or anything like that. I'm not an electrical engineer. So even with all my background in safety and rolling out these kind of programs and doing this training, I am not qualified to actually do work on that. Now, as a side note, I've done electric work in the past, but nothing to the extent of what these trained and authorized personnel are. Flash protection boundaries. Okay, the flash protection boundary is a distance from exposed live parts within which a person could receive a second-degree burn if an arc flash were to occur. That's an unprotected person. Now, this has recently changed. They've gone away from this, the second-degree burn, but a second-degree burn, they've updated it recently, but a second-degree burn is still very serious. So a flash protection boundary is going to protect somebody that, if exposed, again, not having any arc flash PPE on, personal protective equipment on, will still result in a second-degree burn. That's not saying they're not going to get burned. That's a key factor to understand. But it's going to save somebody's life. All right, flash protection boundaries. Arc flash PPE is required within this boundary. So the flash protection boundary for voltages below 600 volts is 4 feet per NFPA 70E guidelines. So for work to commence, or an electrician working on a piece of equipment, they have to be properly outfitted with the right arc flash personal protective equipment. They got to have the right training. They got to have the right insulated tools, etc. Flash protection boundaries. So it is critical to protect an unqualified person from a shock and arc flash hazard by utilizing appropriate barrier warnings. Ideally, you want the area where any arc flash can occur to be cordoned off, physically separated off, ideally controlled and in a locked environment, like let's say an MCC room or something like that. But if it can't be, because of the physical layout, you want barrier tape up, you want barrier posts, certainly you want signage. and use an attendant as needed. Now, this would be, an attendant would be something where a good example of that would be like if you're conducting a facility tour and you've got, let's say, a group of potential customers in, or, maybe another group from another plant if you're part of a larger organization. An attendant can keep people kind of on. You should always have a designated path where you do a tour throughout your plant, keeping people away from, certainly as we're talking about arc flash hazards, but any hazards relating to any industrial environment, machinery, fall protection, etc. And an attendant can be helpful in that purpose. Now, arc flash PPE requirements. The NFPA has established detailed guidelines related to personal protective equipment related or required for each hazard risk category. The hazard risk categories are important to know. These guidelines are included in the Electric Safe Work Practices Code of NFPA 70E. OSHA also requires PPE to be worn under OSHA 1910 Part 335A1I. 1910 is general industry. As a side note, OSHA has two standards, general industry and construction. If you ever see OSHA 1926 or CFR 1926 is talking about construction. This particular standard falls under general industry, personal protective equipment. So OSHA requires, or PPE is required when employees are working in areas where potential electrical hazards exist, shall be appropriate for the specific parts of the body to be protected, and shall be appropriate to protect the worker from the task being performed. So it's critical to have that arc flash hazard analysis done to know what the arc flash hazard rankings are or ratings are, and the arc flash PPE requirements meet those arc flash ratings. And again, you train your employees on those. Now, we've talked about an arc flash hazard evaluation. An arc flash hazard evaluation is needed to determine what specific personal protective equipment is needed. If your plant hasn't done one, I highly recommend getting it done as soon as possible. Now, I'll warn you, it is not cheap to do. This can run into the thousands or tens of thousands of dollars if you don't have the resources internally to do it. But in my opinion, my strong opinion, it is money well spent. And basically, it's a measure of how much electrical energy could be released in a phase-to-phase or phase-to-ground electrical discharge by a trained, competent electrical engineer. So, arc flash PPE could include, and this is by no means an all-inclusive list, FR, fire retardant, flame retardant rated clothing, flash hood, jacket and bib overalls, and face and eye protection. Basically, when you go into an arc flash hazard potential, for the most part, again, depending on how high the risk is for the energy potential release, pretty much your whole body is going to be covered. You want to protect, everything, especially from burns, from all those hazards that we talked about on the first few slides. Okay, this is an important slide. So right now there are 4 hazard risk categories. And as you can see, the higher the hazard risk category, the more potential energy release there is in terms of kilocalories or calories per centimeter squared, and the more arc flash PPE is required, and the more protection is required. And once again, these hazard risk categories are determined by arc flash hazard analysis, and those are done by trained and authorized electrical engineers or somebody with that background. So a hazard risk category of 1 has a required minimum arc rating of potential 4 kilocalories. At a basic minimum, it's an arc flash FR shirt, FR pants, or FR coverall. Again, this is generic. Each piece of equipment is going to be specific. That's going to be rated by that arc flash hazard analysis and reflected on that arc flash hazard warning label. We'll talk about warning labels here in a few slides. Hazard risk category 2, again, the PPE builds on the previous one. So arc rated FR shirt, pants, and coverall at a minimum. Again, more detailed PPE is required or may be required for each piece of equipment. That has a required minimum arc rating of 8. Once you get into hazard risk category 3 and 4, the arc flash potential expands greatly. So more PPE is required, and the more energy potential can be released. So a hazard risk category 3, you have an arc flash FR shirt, FR pants, FR coverall, and an arc flash suit selected so the system arc rating meets the required minimum, and any additional PPE required for that piece of equipment. And a hazard risk category of 4, an arc flash FR shirt, FR pants, FR coverall, and arc flash suit selected so the system arc rating meets the required minimum. Now, as I mentioned before, that goes up to 40 kilocalories. Once again, anything above 40 and above kilocalories, PPE, at least at this point in time, just cannot physically protect the body. The body cannot absorb physically that much energy being released. So work cannot or should not be permitted. Arc flash labeling requirements. You want to label each system location for the arc flash hazard boundaries, the shock hazard boundaries, and the combined levels of PPE. The labeling requirements designed for industrial environment, they should be sturdy, highly visible, 5" by 3 5/8 inch, chemical resistant, UV resistant, and washable and durable. You don't want them fading or wearing off or fading out. And if they do, then they need to be replaced. And that should be part of your arc flash program, is once these labels are up, to make sure that the labels are still legible and certainly employees are following them. So here is one example. They come in many forms. This is courtesy of Brady. Now this is a blank one for demonstration purposes, but a lot of information is given on an arc flash label. And again, this is going to be determined by your arc flash hazard analysis. So you got the nominal system voltage listed, the arc flash boundary, we talked about that, the restricted and limited approach, the incident energy in calories per centimeter squared or kilocalories, the working distance or PPE hazard category arc flash rating of clothing. So you'll have the hazard risk category, you'll have your PPE, and then additional PPE is required. And this arc flash warning label is going to be different for each piece of equipment because they're different hazards. So each piece of equipment needs to be evaluated, needs to be analyzed, needs to have this label on, and then your employees trained to follow and understand the requirements and have the right PPE to follow and to wear. All right. If an employee has to work on or near live electric parts, it has to be placed in electrically safe work condition. You got to have the right training in place. You got to have the right planning and the right personal protective equipment. Ideally, no work should be done on live electric, but again, with the understanding that it has to be done occasionally for troubleshooting, or like the example I gave in like working on life support in the hospital. All right, qualified person. So the definition is one who has the skills and knowledge related to the construction and operation of the electrical equipment and installations and has received safety training on the hazards involved. Once again, I am not qualified to actually work around arc flash equipment. I don't have that skill set. I'm training on what the standard is and what the requirements are. And you may or may not be. If you're a trained electrician and you've got the skill set, you've been through the training, etc., great. But again, I'm not. And you want to make sure only qualified and authorized personnel do this kind of work. All right. NFPA requirements for work on or near live electric parts. De-energize completely before an employee works on them, lockout, tagout. If it's infeasible to de-energize, you've got an increased hazard, obviously. You got to look at equipment design, operational limitations. But there is a big difference between infeasible versus inconvenient. If something's inconvenient, it's got to be de-energized. The standard doesn't account for that. If it's infeasible, meaning it has to be energized because of, let's say, troubleshooting or whatever the case may be, then it trips the requirements for working on live electric parts, or if it's below 50 volts. So NFPA requirements for work on or near live electric parts, you got to have an energized electrical work permit. You have to conduct a hazard risk analysis with all the parties involved. You got to make sure you have the right personal protective equipment on. You have the right training, so a qualified person, and you got to do a job briefing. So a lot of steps need to be involved and should be involved. Don't shortcut any of these steps. Not only are you violating the consensus standard, but you're putting your employees at significant risk and opening up, potential very serious injury or fatality or multiple injuries or fatalities.